regular polygon. When I'm trying to find the area of a regular polygon, I can't find the area of the whole polygon at once, but rather I want to split my polygon into smaller shapes to help me find the total area. In this instance, we're going to say that if a regular polygon has n sides, I can divide that polygon into n congruent isosceles triangles. Now this is important because I can then take my number of triangles and use that combined with the area of one triangle to get the total area of my polygon. If you look at this first picture here, I've drawn an entagon. You'll notice I specifically haven't finished the top because we don't know for sure how many sides we have. But I do know a couple things. I do know that the distance from the center of my polygon to one vertex is called the radius. And I know that if I take all of my isosceles triangles and I imagine drawing lines from each vertex to the center, I'm going to end up with a bunch of angles that make up the center of my polygon. Now the angles that form the center of my polygon are going to form a circle, which measures 360 degrees. Now because of that, I can say that one of my angles in the center of that polygon is equal to 360 degrees divided by n. Now that angle, which equals 360 degrees divided by n, is what I'm going to call my central angle. But now let's take that small triangle, that small isosceles triangle that we're looking at right here. And let's blow that triangle up. Oh look, I've drawn in one of my isosceles triangles here. You'll notice we still have the radius to the side. And in fact, each side of that triangle is the same length, one radius long. But you'll notice here I've drawn an extra line in. That extra line that I've drawn in comes from the center of the circle, or not so much the circle, but the center of the polygon, down to the base of my isosceles triangle, and it forms a 90-degree angle. I'm going to call that height my altitude. And you'll notice that my altitude does two different things. The entire base of my isosceles triangle is now cut into two equal halves. And my central angle up here is now cut into two halves. So to get one side, I divide my central angle by 2. And we've discovered and looked all of this even without a toolkit. But now we're just going to formalize the process so that it's a little simpler moving forward. Let's get going. I want you to find me the area of a regular nonagon with the radius of 4. Really big key anytime we're working this chapter, I want you to sketch and label the triangle as you go. Now personally, that means I end up drawing multiple triangles. And you don't have to draw multiple triangles, only if it helps you out. So I'm going to get started with my first step. I want to find the central angle. And if you're having trouble figuring out what your central angle is, I want to remember that a nonagon has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. And when I think about those 9 sides, I'm not necessarily going to want to draw the entire thing. But what that tells me is that my central angles will total 9. So that middle circle is going to be split into 9 pieces or 9 triangles. So 360 degrees divided by 9 equals 40 degrees. That's my central angle. And since they told me that I have a radius of 4, I'm going to label each side of that isosceles triangle as 4. Step 2 asks me to find the base of my isosceles triangle. So the first thing I'm going to do is personally, I need to take my isosceles triangle and I need to draw him. Just a little bit neater so that he's out of the way from all the other stuff. So we're going to come in here, draw my isosceles triangle, nice and neat. Now I know that my radius is 4. And I know that my central angle was 40 degrees. But what I'm going to do is I'm going to come in here and I'm going to draw my height in, my altitude. And forming a 90-degree angle with the base. What that does is this allows me to take my 40-degree central angle and split it into 2 20-degree angles. Now, if we look at the base of the isosceles triangle, I know that both the left-hand side and the right-hand side are the same length. I'm going to label each of those X. And then I'm going to get really excited because I now can tell you how to solve for one of those X's. If I think about my triangle, but I pull out just one side of the triangle, let's pull out the left-hand side and think about that for a minute. I have a 90-degree triangle where I know an angle, a side, and I want to know the other side. I'm going to use trig. If I look at my triangle carefully, you'll notice that the X is opposite of the 20 degrees, and the 4 is the hypotenuse. So I'm going to use the fact that the sine of theta equals opposite over hypotenuse. So the sine of 20 degrees equals X divided by 4. Going to multiply both the left and the right by 4. X equals 4 times the sine of 20 degrees, which is, you're going to want your calculator for this. If you don't already have it, send someone from your group back to make sure that you punch this up right. So I'm just pulling mine out. Remember, you're working in degrees. 4 times the sine of 20 degrees is approximately 1.368. But to get my entire base, I take that times 2 for my base, and I end up with 1.368 times 2, or approximately 2.736. So I almost have my entire triangle's information. But when I'm trying to find the area of a triangle, I don't need just the base. I also need the height. Now, if I look at this triangle, I can label the height with the letter Y. That's my adjacent side when I compare him to the 20 degrees. So I know my adjacent, or I want my adjacent. I know my hypotenuse. I'm going to say that the cosine of theta equals adjacent over hypotenuse. Or the cosine of 20 degrees equals y over 4. Gonna multiply both sides by 4. Y equals 4 times the cosine of 20 degrees. Pull up my calculator. 4 times the cosine of 20 degrees gives me approximately 3.759. Once we have that, I want to find the area of one isosceles triangle. That's my base times my height, divided by 2. So base, height, divided by 2. So for this triangle, that's going to be 2.736 times 3.759, all divided by 2. Which is going to give me, and again, you should all be typing this up in your calculator to make sure that your numbers work out right. Means we have an area of approximately 10.285 units squared. But we're not done. We're calculating the area of not a single isosceles triangle, but of a nonagon, which has 9 sides. And since it has 9 sides, it has 9 isosceles triangles. So 9 times 10.285 units squared will give me 10.285. Approximately 92.562 units squared. And that is how I find the area of a regular polygon.